Hello everyone, thanks for stopping by. My name is Strapum and today I'm here to walk you through our work called LATB, which stands for Language Aware Token Boosting. This work is joint collaboration between SCB DataX, Tsinghua University and the XGBX company. So in a very short summary, we reduce the language confusion in large language models at inference time without any fine-tuning or without any additional data. So let me show you what that means and let me show you how it works. So let's start with the problem we are tackling here. It is called language confusion. A lot of most capable open models like Llama 3 are English centric. They were trained predominantly on English, and what happened is when you prompt them in non-English language, let's say Thai, Korean, or Arabic, the model often fails to reliably respond in that language consistently. It drifts back into English and verse. It mixes scripts mid-sentence. So I give you an example from the real response from Llama 3 in the box that I point here. You can see the output starts in Thai, then it suddenly switches into English, throws in some Chinese characters or even some Cyrillics, all in a single response. And the problem compounds. Once the model produces confused token, it tends to keep going off the rails, and because this, the snowballing hallucination effects. One bad token cascades into completely broken output. Now, there are existing fixes for this. You can do supervised fine-tuning, you can use few-shot prompting, you can lower the temperature, but these either expensive, they need extra compute and data, or they're just unreliable, they don't consistently solve it. So our question was, can we fix this purely at inference time without touching the model weights or without having extra compute for training and additional data for training at all? The answer is yes. Alright, the core idea is something we call logic perturbation, and here's the intuition. So right before the model applies a softmax to pick the next token, we step in and nudge the logics. Specifically, we identify which token belongs to the target language. We just do this by the Unicode filtering, and we add uniform boost to those tokens. That's the entire method for the vanilla version, and we call it vanilla LATB. So to zoom in, we do 3 steps. First, we just get the logic from the model, then we add the bias to the language specific tokens, and then apply the softmax as usual. It is almost embarrassingly simple, and that's kind of the point because there's no training, just a small intervention at decoding time. But we notice a problem if you always boost even when the model is already confident and correct. You can actually hurt the output quality because you're distorting the distortion that didn't need fixing. So we built the more sophisticated version of LATB and we call it adaptive LATB. The idea here is only boost when the model is actually uncertain about which language to produce. So we look into the gap between top in language token and top out language token. If this gap is small, meaning that the model is confused which language to produce, so then we apply the boost. And if the model is already confident, we leave it completely alone. There is a confidence margin beta between 0 and 1, and that gates these whole things. So here is a quick example of why adaptive boosting matters. Both columns summarize the same report. On the left, vanilla LATB with alpha too high forces even English acronym into Thai. UNODC and TIJ get translated into clunky Thai spelling, and it oversuppresses and distorts into Thai. In the meanwhile, adaptive LATB only boosts when the model is actually confused, so it leaves this acronym alone. So someone might ask that when I boost the logits, am I just trade the model output quality with the language confusion? The answer is no, and we have the theoretical support here that when we boost the logits, the token within the same language will have the same probability ratio before it is boosted. This makes the algorithm works magically. Okay, does it actually work in practice? So we did the experiment. We used Llama 3 8B instruct as our base model, which is English centric, and we evaluate on the XL sum, which is the summarization datasets across 8 languages. We choose 4 high resource languages, consists of Russian, Chinese, Japanese, and French, and another 4 mid resource languages, Korean, Thai, Hindi, and Arabic. We compare against the base model with both normal and strict prompt, and against Susume, which is the 8B model that was specifically fine-tuned version of Llama 3 8B to be multilingual. Okay, let's look at the results. The first table represents language confusion measured in token level, line level, and response level. The lower is better, and the headline result is that both LATB and adaptive LATB dramatically cut the language confusion compared to the base model. In several cases, we are bringing the language confusion down close to zero. And remember, we are doing this with zero training, while Susume needs a full fine-tuning run. If we are looking at the second table, it represents the summarization quality. We measure it by ROG score. The higher is better, and the important key takeaway is that we maintain the summarization quality, so we are not sacrificing the fluency or the content to get the language right, as we proved in the theoretical analysis before that it does not change the probability ratio between tokens within the same language. We also study hyperparameter carefully for both boost value alpha in the vanilla LATB and the confidence ratio beta in the adaptive LATB. We found that an inverted U relationship. Moderate value are the sweet spots. They minimize the language confusion while keeping the ROG high. But if you go to extreme, you always suppress the non-target tokens and the quality degrades. So there is a clean interpretable trade-off of the optimal region is pretty broad, which makes it practical to tune. So to wrap up, LATB is a tuning-free recipe for multilingual alignment. We just perturb the logits at the token level during the inference. We introduced 2 variants, the vanilla LATB and the adaptive one. So both significantly reduce the language confusion versus the base model with no additional training. I'll be honest with the limitation too. First, it is weak on the OOV tokens. Second, our Unicode-based language identification struggle with the language that share the same Latin scripts, since you cannot cleanly separate them by the character ranges. And third, it does still need some hyperparameter tuning to hit that sweet spot. But overall, we think this is a very practical tool. If you have got English-centric model and you need it to behave in other languages right now without retraining, LATB gives you a simple way to do that. And that's our work. I would love to hear your thoughts and I'm happy to take any question. Thank you.